Welcome to the YouTube channel for the Critical Thinking Center at the University of Wisconsin-Stevens Point. I'm Donna Warren, and I'm director of the center. And today, I would like to talk a little bit about decision-making, which, as you can see, we're understanding to be the process of selecting from among a set of sort of predetermined or given options. The question is, how can we do that most effectively? Obviously, there are a lot of factors to consider, but the one that I would like to discuss today is just the question, am I looking ahead? Because when we decide to do something, it's the future consequences that we should consider, right? So here is a standard decision-making framework. If we realize that we have a set number of options, I'll call them X, Y, and Z, in order to decide that we should do X, we need to determine that X has essentially a competitive advantage over options X and Y. What kind of advantage would that be? Well, the technical term is expected utility. It's essentially the process of thinking about the consequences of these potential actions and considering both how good or bad would those consequences be and how likely or unlikely would those consequences be. We need to consider what the consequences are, how much we want them, and how likely they are. So, an example. Suppose that we're working for a corporation and we produce something, and our current product isn't doing as well as we would like, and we have a few options. One option would be just maintain the old product and not do anything different. Another option would be, let's maintain the old product and maybe introduce a new one. The third option might be, let's just abandon the old product completely and just focus on the new one, right? Option 3. In order to decide what the expected utility of each of these outcomes is, we have to think about what are the consequences of each of those options, how likely are those consequences, and how good or bad are they. So let's go down here and consider the expected utility of maintaining the old product and not starting the new one. Suppose our old product is doing sufficiently badly that there's a 10% chance that we might earn $400,000 if we just keep on doing what we're doing, but there's a 90% chance that we're going to lose $100,000. In order to decide what the expected utility is, we need to multiply the probability of an outcome happening to the goodness or badness, in this case, profit or loss of that option, and then add those numbers up. So we have 10% times 400 plus 90% times negative 100, and the expected utility there is minus 50. So we can expect that if that was the process that we continued over time, just doing what we've done before, we can expect to lose on average 50 grand a year. Now suppose we're going to consider the second option, maintain the old product and start a new one. We think that maybe there's a 70% chance of earning $250,000 if we do that, and a 30% chance of losing $150,000. Multiplying those numbers up, doing the math, well, that's better. That's a lot better. There's an expected utility of gaining $130,000 a year if we keep the old and start the new. But now consider what happens if we just ditch the old entirely. There, because we might have more resources to funnel into this new product, there might be an 80% chance of earning $300,000 a year. And of course, there's always risk. There's a 20% chance of losing $150,000. Adding those numbers up, what we get is an expected utility of $210,000 a year. That's by far the best one, right? So that's what we should do. Do the thing that has the highest expected utility. Now, there's a lot of questions here. How do we decide what these probabilities are? How do we know how likely it is that we're going to gain or lose money? How do we figure out how much we would gain or lose under each of these scenarios? How does this apply to something that's not as obviously quantitative, where we're not looking at essentially literally the bottom line? What's going to be our profit or loss? These are all really good questions, but what I want us to think about right now is what we are not looking at. We're not looking at what happened before. we're looking entirely at where are we going. We're looking at the future. We're looking ahead. Here is what we don't consider, and I'm going to reposition myself here so you can see this over here. What we do not consider is how much money we have already spent in the old product. This would be an objection to, sorry about that. This would be an objection to not divesting from our old product. We could say, but look, we've already invested $500,000 into this old product. And clearly we shouldn't abandon things that we've already spent a lot of time and energy on, right? We want to honor our previous investment. But often we don't. Assuming that we always do is the sunk costs fallacy. Thinking that when we make forward-looking decisions, we need to consider time and energy that we've already spent. We've already lost it. It doesn't necessarily need to dictate, and in fact, it might not even properly influence the decisions that we make going forward. That's the sunk cost fallacy. I think it's incredibly useful. We can consider it when we think about whether we should start investing in a new product and abandon an old one. We might consider it when we're thinking about whether we want to move to a different city or whether we want to change jobs or any number of things. Just think about that. Do you want to consider the amount of money and time and energy that you've already spent? Or do you want to think, hey, you know, that's gone. I'm not getting that back. Unless that actually actively affects what's going to happen going forward, maybe I should just let that go. Let those sunk costs be sunk and look ahead. So that's decision making. I'll talk to you next time. Bye-bye.